Well, this is another example on Bayes' theorem. This one is more of an healthcare application. Mammograms are 80% effective in detecting breast cancer. However, their false positive rate is 10%. Suppose that 0.08% of persons tested actually have breast cancer. What is the probability a person has breast cancer given that the mammogram detected cancer? Okay, again, you might need to read this a couple more times, and I suggest you take your time and start defining these percentages in terms of probability notations. Define some events and write these probabilities down. And you already know that this is an application of Bayes' theorem, so have that in mind when you're calculating what this problem is asking for. All right, let's go ahead. Here it says 80% effective. Mammograms are 80% effective in detecting breast cancer. So when they say effective, this is not super clear, but when mammograms are effective, that means when cancer exists, they are able to detect them, and that's 80%. So I'm trying to use a terminology that relates to conditional probability terminology. Given that breast cancer exists, probability that mammogram detect them is 80%. So I'm going to write that down as probability that mammogram detect cancer given that cancer exists. However, their false positive rate is 10%. So false positive means mammogram says it's a cancer, but it's really not. That's what false positive means. So mammogram says it's cancer, but it's not. Not cancer is C prime, C complement. Suppose that 0.08% of persons tested actually have breast cancer. So that's basically a statistic on percentage of people that have breast cancer. So you can easily say that this is probability of cancer, right? Regardless of what mammogram says. But ultimately, they figured that 0.08% of people really have breast cancer, which is really low. What is the probability a person has breast cancer given that the mammogram detected cancer? So by reading this sentence, you can clearly see that it's the opposite of this probability. It's asking us what is the probability that cancer exists given that mammogram says it exists. So you always look for words like given, knowing that, and things like that that gives you a conditional probability hint. So, is a clear application of Bayes' theorem. You have probability of MC given C, you're looking for probability of C given MC. So following the Bayes' theorem formula, this is going to be probability of MC given C times probability of C over probability of MC. Again, this is not directly given in the problem, but you can use the total probability rule to calculate it, and that's exactly what you have in the Bayes' theorem formula. Right here is the total probability rule for probability of B in this case, which was the second, the given information in the conditional probability. So I can replace that with probability of MC given C times probability of C plus probability of MC given C prime times probability of C prime. And on the top we have probability of MC given C, probability of C. So you have all the numbers 0.8, 0.0008, and same. And here we have 0.1, and this is 1 minus probability of C, which is 0.9992, I believe. So when you do the math, you will get 0.006. Small percentage. That's the probability that you actually have a great breast cancer given that mammogram says you do.